Welcome everyone. Thank you for attending this session. The topic of the session is future-proofing solutions with Azure Blockchain Workbench. And the prefix for this session was community meetup. Now, why is this a community meetup? That's because I more or less represent the Dutch .NET community. A lot of people from the Dutch .NET community are currently in Redmond because of the MVP Summit, but I'm not, I'm here. I will talk to you about a technology that is a passion of mine, fascinating for me, and hopefully for you as well. The content of this session will be around what Microsoft is doing in the blockchain space. How do you deploy and use Azure Blockchain Workbench? And specifically, we will talk about the REST API that is available for Azure Blockchain Workbench. Now, to start, I'm not going to explain the core technology of blockchain. I suppose, I hope that everyone is more or less familiar with the concept of blockchains. I'm not going to talk about cryptocurrencies or how to make money in the area, although you may make money as a developer, because developer in the blockchain developer are highly sought after. But to be completely on the same page for everyone, I just want to make sure that everybody understands, the core, the basic concepts of blockchain, which is it's a ledger where data is stored, it's shared. The data in that ledger is shared by everyone in the network. Every transaction that is added to the blockchain has to be approved by some form of consensus. So there's a consensus algorithm necessary. And once a transaction is stored in the blockchain, it cannot be changed. It cannot be deleted. So if you have to more or less revert a transaction, you just have to add another transaction to revert the change that you would want. So that's the basic idea of a blockchain. But there's a bit of a problem with the blockchain, the way it was designed and conceived about a decade ago, because they were designed to use on public networks. The Bitcoin network, the Ethereum network, all of those networks are public. Everybody can see them. Everybody can join the network if they want to. And as a result, also, the network has limited performance, and there's little confidentiality. Everything is transparent on the blockchain. Everyone can see what's going on the blockchain. Also, especially for enterprises, we need integration. You need integration of a blockchain with existing systems, and connecting to existing infrastructure is difficult. And also expensive. If you're in an enterprise as a developer or an architect or even somewhere in management, you have some challenges that you have to overcome, because the questions you usually have are, what vendors will be around for the long haul? If you've been monitoring a little bit the blockchain space, the technologies that are coming up, they come up and they move away, and you never hear from some of the projects ever again. So you have to understand what vendors are around for the long haul. Another problem that you have is that it's time-consuming to to build up an infrastructure. You know, an infrastructure has lots of components, lots of elements that you need to set up, that you have to configure, and that's time-consuming. Also, as I mentioned before, everything is transparent, and if you're in a business, you don't want all your data just, you know, out in the open on an unsecure platform where everybody can see what's going on, everybody can see the agreements that you made with your suppliers. You don't want that. And so the question is, how do you connect a blockchain application or an application that uses the blockchain in an existing infrastructure? That's the big issue. Implementation is complicated. You have to manage the keys, you have to manage the APIs, you have to build web clients, writing the business logic. That's a lot of stuff going on if you want to build blockchain applications. So what is Microsoft doing in this area? Microsoft introduced the Azure Blockchain Workbench last year as a collection of Azure services to help you create and deploy applications, and also scaffolds the infrastructure to enable developers, so that developers can focus on writing the business logic in the form of a smart contract. And Azure Blockchain Workbench also makes it easier to integrate several Azure services, such as Service Bus and Event Grid, and other capabilities to help automate the different development tasks. There's a REST API, as I mentioned before. There's data and reporting options, also convenient. And there's a lot of sample projects and documentation. So how do you go about and set up the Azure Blockchain Workbench? There are 4 steps, effectively. All 4 steps the Azure Blockchain Workbench will walk you through all these 4 steps. And one of the first thing you have to do, or have Blockchain Workbench do for you, is setting up an Ethereum proof of authority network. Now, a proof of authority network is a little bit different than a network, than a common Ethereum network, which is currently running on a proof of work algorithm, because proof of authority is an alternative consensus algorithm, and the mining nodes, the nodes that are doing the validation of the transactions and adding blocks to the blockchain, those are effectively called validators. And so in a proof of authority, the node is selected because of its identity, and not because of its ability to do complex calculations like a proof of work node would do. And the validators are picked just at random. Another requirement is also the Azure AD tenant. And the Azure AD tenant is necessary so you can authenticate users to access the blockchain apps, access the APIs, and read profile information. So these are the 4 steps. And I'll just give you a quick demo of what that would look like. Okay, let's see. Yeah, so here's my my Azure portal, and you can simply create a new resource, and the blockchain options are way at the bottom. Don't know why. Should be at the top, but that's just my opinion. And you can see that Microsoft is investing a lot of energy and time and resources in offering blockchain solutions. You can spin up an Ethereum blockchain very quickly. You can use Hyperledger, Quorum, Corda. There's lots of different ledgers available. And there's the Azure Blockchain Workbench toolkit that you have here. So in order to create the blockchain workbench, you just fill in the required elements. I'm just entering some of that data here. Now, don't worry that we're going to have to wait for the whole deployment to be complete. Just want to show you what the elements are. And it's always nice to have create a new container, a new resource group, so you can find them, find all the resources that are in your deployment later. Okay, so the basics are just easily done. Now the advanced settings are more important. You can either choose to create a new blockchain network, or you can use an existing one. If you create a new, the one thing you have to remember is that this will deploy your proof of authority Ethereum network on a few nodes, and those nodes are not publicly accessible by default. They have private IP addresses. Obviously, the APIs that Workbench uses can access them, but you cannot access them yourself. If you want to access the blockchain also yourself externally, or if you want other parties involved in your blockchain, it's best to first create your proof of authority network first, and then use the Ethereum RPC endpoint and here. Okay. So there's Active Directory settings. The Active Directory settings, you would have to use a domain name, a tenant, and an application ID. Now, the application ID is important to because that is the application registration that is used by the blockchain API. So we could go over to Active Directory just to give you a quick view. Look at the application registrations, and you can see I'm running out of credit here. Yeah, just I'll show you how much resources will be deployed in an instant. But I just wanted to let you know that if you deploy this using all the defaults, this implementation will cost you around €9 per day. So, as a hobby, it may be expensive, but in a company, maybe not so much. Okay, so the application registration is necessary to enable the blockchain API to access all the different elements of the blockchain network. So I'm not going to go and change all this. I'm not going to okay this because I've already done this, and the end result of this deployment is this, where it takes about 30 to 60 minutes for the whole deployment to complete. So what do you get then? You get 2 app services. You get application insights, you get the event grid, key vaults, SQL database, storage accounts, virtual machine scale set for the ledger nodes, and 2 virtual machines for as validator nodes. Obviously, if you're running a complicated blockchain application, if you need more performance, you can scale up the virtual machines, and you can scale out the virtual machine scale set if necessary. So that's the resource that you get, and when you complete the deployment, you also get a dashboard where you can manage your applications. You can see I've already deployed a single application, and you can see we have members. We can add a new application. I'm going to show you a little bit how that works later on. And that's it. This is the basic interface that you have for managing your applications in the Azure Blockchain Workbench. Okay. So what do you do if you have your deployment completed? How do you create your Workbench your blockchain application? It's a matter of 4 steps. You configure it. This configuration is done in a JSON file. The JSON file contains metadata on the various items of your application. You create a smart contract file, and because we're using Ethereum as the network, the programming language that you use for these smart contracts is Solidity. That's a requirement. Now, the idea is that Microsoft will invest and add new types of ledgers to this blockchain workbench, but as of today, it's just Ethereum and therefore Solidity. If you have those 2 files, then you add those 2 files to the blockchain workbench, and you add members to use the application effectively. Now, the configuration metadata is, as I said, is a JSON file. There are a couple of important elements. Now, obviously, there's an application name, there's a display name. Those are just the things that you can see in the dashboard. And but more importantly are the application roles. And the application roles are important because they describe who can do what on the smart contracts that you are deploying. In this case, we're just talking about a very simple API that has a requester and a responder. So there's 2 roles, and that means that once you assign members to the application, you can assign them one of these roles. Another element that is relevant is the workflow. And the various workflows represent the smart contracts themselves. Obviously, we need the smart contract itself. Now, this is a very simple smart contract. If you're familiar with Solidity, if you're familiar with writing, who is actually, a show of hands, who writes their own Solidity code already? No? Okay. Okay, so this is a bit of a challenge perhaps because it may resemble, it looks like JavaScript, but it's not. It's effectively, it's something completely different. But it's, if you want to write smart contracts, you have to learn this language. Okay, so how do you go about? And deploy this. Okay, let's have a quick look at the JSON file. As I said, it's the configuration. It's just metadata. It's a lot of metadata, actually. It represents the various states that your application can have. And then there's the Solidity file, which is actually not that large. You can upload these very simply by clicking New, browse to the relevant JSON file. It will check, and it will also check the Solidity file. One thing you have to remember, as I learned while preparing this and working with the Workbench, is that you have to make sure that in the JSON file, the application name here is exactly the same as the file name of the Solidity file. If they're not the same, then Workbench dashboard will complain that it's not able to upload the new application. And once you've done that, you can go to the application. As you can see, I've already, as a matter of testing out my application, I've already submitted some requests. And you can see that I have the different various members. Actually, I have two accounts. One is a responder and one is a requester. And you can also see that I have an API endpoint that I'll be using later on in this talk. So that's quite easy to do. You just add a member, and I have someone else in my list. And okay, so where do these people come from? They come from my Azure Active Directory user list. You can add new users, guest users if you want, and those are the users that you will see available here in this list. Okay. Okay. So I'm going to demonstrate a couple of ways to interact with the blockchain application. In this case, by using the REST API. There are other ways to interact with the blockchain application. One of those ways, of course, is the dashboard that I just showed you. But this is not something you would normally do in a business environment. You don't want to expose your customer or your users to that dashboard because it's not fitting, probably fitting with your line of business applications. Most common is using the REST API, but there's also another way because it's all about sending messages to the blockchain. And messages in Azure are done through Service Bus and Event Grid. So you can also use Service Bus and Event Grid to send out the messages to the blockchain. Normally, those messages have to be a certain format. So the blockchain APIs understand what so the blockchain API understands the messages that are being sent. So if those messages that you are sending from your business application do not correspond to the messages that are required by the API, then you would have to use something like a logic app or an Azure function to modify those messages to the known format that is necessary. Okay, so there's three options that I'm going to show you. One is with Postman. Postman is a testing tool for testing a REST API. We can use a service principal. that will act on its own, interact on its own with the API. And finally, I'm going to show you a web application. And just before I'm going to show you the those three options, I just want to make sure that you understand how sending a transaction actually works. The external system, that's your application, has to authenticate against the Active Directory, returns a token, and then can call the API. The API sends a request message to the service bus, and the API will monitor the SQL database on the status of the transaction that you sent. Now you may wonder, perhaps, so where is the blockchain network in this diagram? Actually, it's targeted by the service bus. So the service bus is actually sending the transactions to the blockchain network and getting results back and feeding the SQL database. Now you might say, okay, but where's the trust then? Isn't this just a centralized way of doing a transaction then? Yes, in a sense, that's true. You still have the blockchain network behind the service bus and behind the SQL database who is actually doing the work. And the SQL database just gives you a visual, is essential to give you a visual representation of the things that are going on in the network. And this is not very unsimilar to the way blockchain explorers work. If you go to a website, if you do I'm going back to a Bitcoin transaction or an Ethereum transaction on a public network, you can see what the status is of that transaction by going to a website, and that website will visualize the state of that transaction. It's not the actual transaction, and in this case, it's the same thing. The SQL database is just giving you an easy way to visualize the content of the Ethereum blockchain. If you really want to dive into the Ethereum blockchain ledger, you can do that. So querying data is the same thing. It needs authentication, calls the API, returns the data, and in this case, if you're just looking at getting the data from the blockchain transaction, you can just simply query. It will simply query the Workbench database. Now, if you want to use Postman to explore and test the APIs that are available, you need a number of things. You need a token name, but that's just a name that you can use for your own benefit. You need a callback URL, and you need the authentication URL, client ID, and the client ID is coming from the app registration that is done in the deployment of the blockchain workbench. Then the state is just a random GUID that you can use, and if you use these fields, you use these parameters, you can get a token for getting for accessing the API. I'm going to show you a little bit how that works. So here I have, is this visible? Here I have the Postman client. I have set up, but I'm not going to show you all the different API calls that are available. You can just look them up on the document in the documentation. The URL for the API is the same, almost the same as the URL for the dashboard, except for the fact that it has API as a suffix. And now, if you're running this, you need OAuth 2, and you need to manage your tokens here. So you can use different tokens if you want to simulate different users. Now, the token normally is, or by default, has an expiration of 1 hour. So when I tested this, it was good, but now obviously it's probably it's not working anymore. So I need a new access token. And as I said, these are the fields that you need. The callback URL is just the name of the Blockchain Workbench dashboard. And this is my tenant. This is the tenant that I'm using. And this is the client ID. Now the client ID is, as I said, is coming from the app registration that you can see here. You see, this is the application ID. It's DA9, etc. And it's the same that I'm using here. So when I request a new token, well, you just saw it flashing briefly, but it gives you a login screen that is authorizing you against the Active Directory. If you just use token, if you want to use different logins just to try out different scenarios or with different users, make sure that you delete the cookies from the Microsoft domain. And so now I have this token, and I can send a request. I'm asking for a list of the applications, and this is what I get as a result. Obviously, there are different APIs that I can use. Let's see what this will give me back. And you see, these are the workflow, one of the workflows that is available. I can start a new workflow. Effectively, starting a new workflow means creating an instance of the smart contract and running the constructor on it, and sending a message if you want. Okay. So this is Postman. Okay. Another way to interact with your application on the blockchain is by using a service principal. The service principal means that you register an app again in the Azure Active Directory. You create an authorization context with the address of the authority, and that means that's effectively the domain name, the tenant that I'm using. You create a client credential with the app ID and a client secret. So there's two steps that you need to be aware of when you register the app in the Azure Active Directory. One is you need to set the permissions, and the second is you need to set a key and a secret to authenticate. This also means that you can use this for the complete scenario and not have a user log in. So you can use this as the service principal will have to be authorized to use the blockchain application. and you wouldn't have a user logging in on on Azure. And then you just simply create an HTTP client, set the authentication header with the token, and off you go. I'm going to show you a little bit how that works. Let's see. If you want to if you want to register your application, as I said, you create a new application. Just type in a name that you can remember. The sign-on URL is not really relevant because you don't have a user signing on, so you can just type in anything you want as long as it's a valid URL, and you could create. And then in the settings, you set the required permissions. You select the API. One thing you may notice is that the blockchain API is not listed here, but if you just type in block, then you will get the blockchain API here as the API to use. And then you set the permissions. And if you set the permissions, make sure that you also grant the permissions, because setting is, for some reason, setting them is not enough. You have to also grant the permissions. And I've done this before. In this particular case, oh, that's not the right one. This one. Yeah. So here I said I have a app registration that I'm using, and this is the application ID. Now, if I go to my code, this is the client application ID that I'm using. You see, that's the same one. And also, you need a key. Now, if you create a new key, you set the expiration, how long you want to use it, and you save it. And you have to be sure that you copy this key right away, because well, you won't be able to retrieve it if you leave this page. So here I have those elements, and if you're interested in making a copy and just copying my secret, that's fine, because I'm going to delete this blockchain workbench deployment anyway, either today or tomorrow, because it's costing me money. Okay, so that's basically all that you have to do, and you can create the authorization context, authentication context that I said, get a client credential, and then basically just list, in this case also list the applications under the authentication of the service principal. This means that you have to add the service principal also as a member to your application, and this is the API endpoint that I registered. Now, there is a bit of a problem in the fact that if I add a member, I can only add members that are known in Active Directory under their name, and not under the GUID, and that's all I have. So you have to do this programmatically. I'm not going to show you how this is done specifically. If you want to know how to do this, I can give you pointers after the talk. But that's a requirement. You have to add the member to be able to run this request. And if we run this, it should give me, well, it's not very elaborate. It's not a very elaborate user interface. It's just giving me a JSON response that I'm just showing here. But that's the same way you can get messages, you can post messages. If you want to start a new workflow, this is the JSON content that you have to start. Well, we can go ahead and see if that works. Let's hope the demo gods are with me today. And so I'm going to start a new workflow. And the reason is okay. The reason phrase is okay, so looks good. That's all it returns. And we should be able to... Okay. And you can see here that I just started this this workflow. A few seconds ago, my API endpoint called the create method. And if you can see here, it was created by the endpoint. It was created. It has a contract address. This is the address that is effectively in the Ethereum blockchain. This is the message that I sent. And you can see also that the status of this message is halfway. And why is that? Because my JSON file here, go back to the JSON file, says here that if you send a request, it can show you that it's 50% complete. And if you respond to this, if you send a respond transaction to this contract, it will show you 90% complete. So I have, for example, I have this one, and you can see that it's 90%. I don't know why it's 90%. It should be 100% because there's nothing else to do anyway. But you can see that it's what the details are of the transaction. And this information you can also get through an API if you want. Oh. Okay. So that's the service principle. And then there's the web app. And now in a web app, obviously, what you would want to do is have a user authenticate. Because you want authenticated users to start transactions on your blockchain application and not have someone who's not authenticated do that. So there is it's a bit of a ceremony going on right now. The user would navigate to the web application. It would redirect to the sign-in, and this sign in would show you the login screen from Azure Active Directory. The user signs in, then we get a token back, and we can use that token in the web application, and this is when the session starts in the web application, an authenticated session in the web application. Now, are we done? No. Because now the Azure AD endpoint, the web application can request a token from the Azure AD endpoint and return that access token. You can use that access token in the header to call the API and then return the resource. Why is this such an elaborate scheme? This is because it's not using a service principal for the authentication. It's combining the the service principal and the user authentication to make an authenticated call to the web API. Now let's see if we can demo that as well. So for this, I again need a number of items. These are the settings in my app settings JSON file. This is just a basic ASP.NET Core API web application. It's using my tenant with the tenant ID for the blockchain application. Again, we need a client ID and a client secret to get the token, that's necessary. And then in my home controller, I'm using the authenticated user to get the token for accessing the API. And from this point forward, actually, from this point, you get the same way of accessing the API as you would do with a service principal. It's just that in this case, we are authenticating with a user. Now, see if that works. As you can see, it's signing me in quickly. Let's just close that to make sure that we start out with an unauthenticated user. And so we log in, and depending on the user, maybe you remember that our application has various members, a responder and a requester. And if I log in with one of these, I can only do one of these things, either request or respond. So go ahead, I'm logging in. And now that I'm logged in, I can call the web API, list workflows. Can I start a new workflow? Let's see if I can do that. No, I cannot do that because I'm logged in as a user who is not a requester. I'm a responder. So I cannot do this. If I sign out and if I sign in again using my requester account, obviously it should work. And start a new workflow. Okay. And the response is 10, and 10 means that it's the 10th request that the 10th contract that I'm currently just started. And it's created by me, by Salma. Okay. So those are the options to, let's go back. Those are the options to access the API. And as I showed you in the API demos, it's just sending back and forth JSON messages. If you if you want to build your application, I would recommend you use the Azure Blockchain Workbench.net SDK, because this will give you type-safe variables to interact with the API. And there's also an integration with Poly.net, which is a resilience library to retry, because maybe your application is not responding as quickly as you want to be, and because transactions that are put on the blockchain now have to be fair. In proof of authority Ethereum network is relatively fast, but it's not instant. It's not if you send a transaction, it's immediately confirmed. It's relatively fast, but it's not immediate. And if you want to do retries, then you would use something like Poly.net. It's a singleton implementation that you can use to access the APIs. It's thread safe. There's exception handling, and there's C# generics that you can use as well. There are a lot of resources available. This is a list of resources that the Blockchain Workbench team at Microsoft is using, is publishing. If you want to know more about the blockchain options that Microsoft is offering, I would recommend you go to BC Block Talk, which is a small, like 10-minute, 20-minute videos from the team explaining the various developments in the blockchain space at Microsoft. Well, you can obviously use Workbench, try Workbench, and it will get you to the documentation, the dev kit, etc. If you scan the QR code, and I think some of you already did, it would be published by now, like 10 minutes ago, an article explaining just what I just showed you on my weblog. And if you want to also keep up to date with the blockchain development, not just Microsoft, but blockchain technology in general, then I would recommend you follow my Twitter account, BC Radar, that I set up. And obviously, you can go and follow Microsoft Blockchain team on Twitter as well. So thank you. We still have about 5 minutes left. If you want, you can ask questions now, or I will be at the Ask the Expert booth after this talk for about an hour or two, maybe 3, depending on who's interested. So thank you. And if you have any questions, let me know. Yeah.
Just a quick question.
Yeah.
When I started using the Azure Workbench, it wasn't clear to me, am I behind the scenes running on Ethereum or Hyperledger?
Yeah, so the question is, if you start Azure Blockchain Workbench, a deployment, are you using Hyperledger or are you using Ethereum? You are using Ethereum. And specifically at this time, it's the proof of authority Ethereum network that you're using. That's the only option available right now, but Microsoft is working to get Hyperledger and Corda as a backend as well.
So then I can use proof of work?
And then you can also use proof of work, yes. Yeah. Any other question? Yes?
To be clear, this Ethereum, this is Microsoft's own Ethereum within Azure. It's Microsoft Trust.
Yeah, yes. So is this the private blockchain or is this the public Ethereum blockchain? It is is a private instance of an Ethereum network. So it's not the public Ethereum network. That's also convenient because you don't have to spend money on executing transactions as you would on the normal public blockchain. And if you set up your own proof of authority Ethereum network, you also have to make sure that you set the gas limit to 0, so as to not require spending Ethereum gas on the network. Yeah. Any other questions? Yeah.
Is there a way to actually set up a public network?
So is there a way to set up a public network? Yes, there is. You can set up, let me show you in the Azure portal. You have a lot of options to create public blockchains. So you can, if you want, you can set up a Hyperledger network, but then you would not be using the blockchain workbench. You can just set up your Hyperledger network. You can set up Corda or Quorum. A lot of ledgers are available, and those are all public. So you would get a public API endpoint, public IP address, and you can connect also other network. So you can connect nodes from other networks just as easily. Yeah. Yeah. Any other questions? Okay. So if you have any questions still lingering, then stop by the Ask the Expert booth, and thank you for your attention.